Hey everyone, I am Dr. Surjit Singh. In this video on Python via examples, we shall talk about the Python dictionaries. Let us begin. Dictionary is an important data type of Python. In this, we save items as key value pairs. Unlike lists, where we search an item using linear or binary search, in a dictionary, search is carried out in a constant time. This is because dictionaries are saved as hash tables, while lists are like arrays. Keys of a dictionary items are unique and unordered and are iterable, but they are not mutable. Unlike keys, the value parts of the items are mutable. In this session, we will also discuss the default dictionaries. We will explore several scenarios where use of dictionary data structure is more advantageous than using lists. We all are familiar with English dictionary. Now let us explore how it relates to the Python dictionary. An English dictionary contains thousands of words, each paired with its meaning. Python's dictionary offers a broader concept by storing words and their meanings as key value pairs, where the word is the key and the meaning is the value. Each key value pair forms an individual entry in the dictionary. Python dictionaries are particularly useful when dealing with a large number of items and when fast key lookup is needed, especially in the situations where keys are frequently added or deleted or their values are modified. Let us revisit the concept of sets, which we covered in the 8th video of this series on Python via examples. In that lesson, we introduced sets as collections of unique items enclosed in braces. Sets store their elements using a hash data structure. While hashing may use extra memory, it significantly speeds up the search operations. While binary search on a sorted list takes login time, searching with a hash structure can be done in a constant time. Hashing is especially useful when working with large datasets where fast searching performance is crucial. In dictionaries, each item is associated with another variable that defines or adds meaning to it, forming a key value pair. For example, veg here is a dictionary of vegetables. The hash memory structure used for sets is expanded to store these pairs, and this expanded structure is referred to as the hash table. For first item of the dictionary, the key is broccoli and its value is a green veg flower. We separate the key and the value by a colon in between them. Print veg prints all the three items of the dictionary. Like in sets, the order in which the items appear in the output of a dictionary is not important. Len of a veg gives the number of items in the dictionary. We can use a key of a dictionary like the index of an array. Print veg caret prints a pink conical veg. Print type of veg gives class dictionary as the output. The keys in a dictionary follow the same restrictions as on the set items. This means the keys must be immutable that cannot appear more than once. While we can add or delete an item for a given key, we cannot modify the key itself. This limitation comes from the way hash memory works, as it assigns each key to a specific memory location. If a key is not in the dictionary, its corresponding memory remains empty. The hash table stores each key along with the link to its associated value. There is no such restriction on the value parts of the items of the dictionary. The items can be of any Python data type. They can be mutable. In fact, we frequently modify the value parts of the items of a dictionary in most of the applications. Like in sets, we use in operator for searching a key in the dictionary. Broccoli in veg is true, while tomato in veg is false. To get the value of a key in the dictionary, we use key as an index of the dictionary. Veg broccoli returns a green veg flower. To add tomato to veg dictionary, we define it as shown in this statement. If we check it now, tomato in veg is true. Len of veg dictionary is now 4, that is the number of its items. We use this statement to add items to the dictionary. Print veg tomato gives a red juicy ball as the output. Keys of a dictionary are iterable. Order of the output is arbitrary. To get the key value pair, we also print vegx and we get this as the output. Let us consider a practical example of dictionaries in which we find the frequency of the letters in a sentence. To save the frequencies, we define an empty dictionary named count. In this, we will save letters of the sentence as the keys and their frequencies as the values. We iterate over all the letters of the sentence. Initial value of x is g. X is not present in the count dictionary, so we add it now. It is the first occurrence of G, so we save value 1 for the key G in the dictionary. In the next iteration, X becomes R. It is not present in count, so we add this also in the dictionary. Initial value of R is also 1. In the next iteration, we look for A in the dictionary and add this also with the value 1, and then we add S1. In the next iteration, we find another S. If expression is now false, and we go to the else part where we increase the value of S by 1. So it becomes 2. Note that value part of an item is mutable. In the next iteration, we make a new entry for the character space. X equal to I makes another new entry in the dictionary. S appears for the third time, so we increase its frequency to 3. This is followed by another space. Its value becomes 2. A capital G is distinct from a lowercase g, so it is entered as a separate item in the dictionary. When key is R, we increase its value to 2. X equal to E gives a new entry while the next E increases its value to 2. Lastly, key equal to N gets the value 1 in the dictionary. The loop over X ends. We now print the dictionary to get the output as shown. Let us simulate a gate that opens for a limited time for the passengers boarding an aeroplane. We have to be very efficient to complete the boarding process in a limited time. For this reason, we maintain the passenger list as a dictionary which provides us fastest searching. We make PNR as the key and the particulars of the passenger as the value that we save as a tuple. Time management is important in this program, so we import the time module. We save the time when we start entry of the passengers and run a loop as long as the difference between the current time and the starting time is less than 30 seconds. 30 seconds is enough to pass 3 passengers in the queue. We manually enter the PNR of the first passenger in the queue using the keyboard, even though modern systems typically use barcode readers which are faster and more accurate. Upper method of Python strings converts the PNR to all capitals, so we do not have to press the caps lock. First of all, we ensure presence of PNR in the flight dictionary. If yes, we extract name, seat number and status of the passenger. We print the particulars and check the status. If it is true, we report the duplicate entry of the passenger. False status means first time entry of the passenger. We now mark the entry of the passenger by changing the status to true. In case we enter the wrong PNR number, we report the error and ask for a fresh PNR number in the next iteration of the loop. After processing the while loop for 30 seconds, we come out of it and announce to a late coming passenger, if any, that the entry gate to the flight has been closed. By simple modifications, we can use this program for the cinema hall entry system. The PNR replaces the ticket number and the value may represent the multiple guests under the same booking. Therefore, we have to replace the value as a list of tuples. Get method of a dictionary is another way to get values for a key. Consider a dictionary of 4 groups of students. Score get2 returns the value of key 2. We store it in X and print it. X is a list of scores. As 5 is not a valid key, get5 returns none. There is no error message and the execution does not stop. We can also give a default value as the second parameter of get. 6 is also not a valid key, but instead of none, we get list 00 as the output this time. However, 3 is a valid key, so default value is ignored and we get value for key 3 in X, that is the list 788. Let us once again recall the program for the frequency distribution. This time we import collections module in the program. This contains default dictionary and we replace our count dictionary with it. In this, we define int as the default data type for the values present in the items of the dictionary. We can run the program now and we'll get the same result. The advantage of default dictionary is that it gives 0 value to all keys that are not present in it. This makes the if statement redundant in the program. For x not present in the count, the default value is 0, that is made 1 by this increment. So the modified program becomes simplified. Not only that the program has become simpler, it runs faster. We increase the count of each item by 1 without checking for its existence. All letters missing in the dictionary automatically get 0 value in the beginning. Output for this program is as shown here. Notice that all values for this output are integers. Default value need not be an int always. If we replace it by list, the default value is an empty list. If we make it tuple, the default value is a tuple with no items and so on. In this session, we described a dictionary that consists of key value pairs separated by colons. The keys of a dictionary are iterable. We also discussed the method to add an item to a dictionary. In operator returns the presence of a key in the dictionary. Key is used as index to get its value in the dictionary. Get method also does the same thing. It can also return a default value if the key is not present in the dictionary. Default dictionary is present in collections. It automatically gives default value for a missing key, which reduces the processing time. I hope you enjoyed the video. Please feel free to ask for further clarifications on my email address given below. I'm looking forward to your comments. Please stay tuned for more such videos.